the last lesson in Unit 2 starts on page 33, and we're going to be looking at graphing. So at the bottom of page 33, you have a place for general notes. We're going to start there with just a few reminders. Last year when you graphed quadratics, they were in the form of a parabola. So the first thing I want to make a note of is a quadratic with an exponent of 2 either looks like this or like this. That's just its general shape. Alright, the next one that we have to know the general shape of is a cubic function. That's got the exponent of 3. That looks like a little snake, like that, or like that. All of those are cubics. Alright, so if you see an exponent of 2, you know it's going to look kind of like the U. If it's got an exponent of 3, it's going to look a little bit like the S. Everything else, 4s, so on and so forth, 4, 5s, that's going to tell you how many turns it makes. A quadratic has 2 turns. So I go down, then I go up. A cubic has 3 turns. 1, 2, 3. So the highest exponent tells you the turns. So I'm going to turn to page 34, and we'll be coming back and forth to that page. 34 talks about the degree of a polynomial. The degree of a polynomial is equal to the greatest exponent. For example, in f of x, its greatest exponent is 3. So that's one of those S graphs. In g of x, the highest exponent is a 5. So the degree of g of x is 5. The degree of f of x is 3. Now the degree tells you the general shape of the graph, what we just talked about on page 33. It also tells you the possible number of turning points, where that graph is going to turn and go in a different direction. And it also tells you the possible number of x-intercepts. So after this, I'm going to go back to page 33 and make a few more notes. Alright, so the degree of that polynomial, that highest exponent, if you have an odd degree, like 3, 5, 7, so on and so forth, that tells you your ends are going to be in the opposite direction. So it's going to look like that. If you have an even degree, that means your ends are going the same direction. So odd degree, ends are opposite direction. Even degree, the ends are in the same direction. Alright? So now I'm going to go back to the bottom of page 34, where it talks about the leading coefficient. The leading coefficient is the coefficient of the variable with the greatest exponent. So in f of x, my greatest exponent is 3, and that is an odd degree. So now I'm going to look at that exponent's coefficient, the number in front of it, and that is a 5. Now the important part about that 5 is that it's a positive 5. Alright, in the next one, I've got an exponent of 5, which is still odd, so my ends are going to do opposites. And it is a negative. The coefficient's negative. So that means my end behavior, my ends, where they're going, is going to flip. It's going to be the opposite of them. Alright, on page 35, end behavior, those ends, what are they doing? The end behavior is the direction of the ends of the graph of the polynomials. After you identify that highest degree, if it's even, it's doing this. They're both going in the same direction. It's going to either both go down, both go up. If it's an odd degree, one's going to go up or down, and vice versa. So odd degree means they go in a different direction. I'm going to go back to page 33 and make a few notes on end behavior. Alright. For the end behavior, if I have, example, negative 5 x to the 5th, I've got an odd exponent, there's my degree, and I've got a negative. Well, let's start with a positive first, make it a little bit easier. So that odd degree tells me my ends are going to be opposite. One's going to be high, one's going to be low, so on and so forth. So So now I'm looking at this positive 5. So that means it's not going to be flipped because it's positive. But that 5 degree tells me that I'm going to have 5 turns. Because that's the exponent. So it's going to have 5 turns, and my end behavior is going to start high and end low. Because it's positive, that 5 is positive, it's going to start high and end low. So if I sketch that out, there's my x-axis, it's going to look 1, 2, 3, 4, 5. It's going to look like that. Start high and end low. If I had negative 5x to the 5th, I still have 5 turns, but I've got a negative. So that means it's going to be flipped. So I'm going to start low and end high. So that would look like, let's see, 1, 2, 3, 1, 2, 3, 4, 5. Start low and end high. All right, if we had, let's look at an even degree. If we had 2x squared. So because it's 2, which is even, our ends are going to go in the same direction. Now, which direction depends on that leading coefficient. Because that leading coefficient is positive, my end behavior is going to look like that. They're both up. If I had negative 2x squared, still even, but the negative means you're going to be flipped, and they're going to both go down. So 2x squared would look like this-ish. Negative 2x squared would look like that. All right? If you had 5x cubed, still have odd, so you also have 3 turns. And because 5, your leading coefficient is positive, means you're going to start low and end high. If you had negative 5x cubed, odd 3 turns, and it's flipped, you're going to start high and end low. It's just the opposite. All right, so now I'm going to go back to page 35, down at the bottom. And sketch some end behavior. First thing I want to find is my highest exponent, my highest degree. So it's 3, so that means it's odd. So I'm going to have 1 in each direction. And that leading coefficient is positive. So I'm going to start low and end high. So I'm just going to sketch it. I'm going to have about 3 turns per my degree, and I'm going to start low, 1, 2, 3. So my end behavior would look like that. All right, the next one, I've got a highest exponent of 3, which is odd, and I've got a negative. So it's going to be the opposite of the one we just did. So it's going to start high and end low. 1, 2, 3. All right, next one. I've got even degree and a positive leading coefficient. So that means because it's even, they're both going to go in the same direction. Because it's positive, they're both going up. And I'm just going to sketch. Oh wait, that should be 4. So that means because it's 4, I'm going to have 4 turns. 1, 2, 3, 4. Alright, next one, I've got a 3, don't pick the 2, because it's not the highest degree. So that's even, that's odd, sorry, and it's positive. So that means it's going to start low, end high, and I'm going to have 3 terms. 1, 2, 3. All right, page 36. All right, now we're actually going to graph them. So I'm going to look at f of x first, x squared plus 3x minus 4, and I'm going to pick out my highest degree, which is 2. And that is an even degree. So that means both of my ends are going to go in the same direction. Now the leading coefficient is positive, so that means they're both going to go up. But if you look at the directions, it says to factor it. So let's factor it. I'm going to multiply to get -4, add to be 3. So that gives us 4 and -1. I just did the x method for the trinomial. So to factor it, I did my x method. Now I want my answers. I want to find my x-intercepts, my solutions. So I'm going to take each factor and set it equal to 0. Or I'm just going to take the opposite of what's in my x. So -4 and +1. Those are my x-intercepts. So I'd go to -4, 1, 2, 3, 4, and I would go to +1. So we found x-intercepts. Now we're going to find the y-intercept. When you find a y-intercept, you plug 0 in for every x value. So if I had x squared plus 3x minus 4, 0, 0. So my y-intercept, if I solve this, is that right there. So I would go to -4, and I would put a point. Okay? Now I'm going to end high, start high and end high, and I'm going to have 2 turns. So start high, I'm going to turn there, and there's the first one graphed. Alright, now I'm going to look at that second one. I'm going to erase this so I have some room. Alright, so the next one, I'm going to go ahead, identify all my terms and stuff. I've got exponent of 3, and that's odd, and it's positive. So that means I'm going to start low and end high. Now I'm going to find all my intercepts. If I have 4 terms, that means I'm going to group it. Let's see, I can take out an x squared, replacing with x plus 1. That second one, I'm going to take out a -1. So they match. Then I'm going to write them together. And I can factor that one more because it's a perfect square. Plus and minus 1. Now if you notice, your factors repeat, +1 and +1. So I don't have to graph it the same number twice, because I can't. But I needed 3 solutions because my exponent was 3. So I'm going to take the opposite of those. So I've got x-intercepts at -1 and 1, because I'm just setting them equal to 0. 1 and 1. To find my y-intercept, I'm just going to plug 0 in for all the x's. When I do that, I get 0 cubed plus 0 squared minus 0 minus 1. So my y-intercept is -1. Okay, now for my end behavior, I'm going to start low and end high. So start low, 1, 2, 3. Just like that. 3 turns, and I'm going to turn at my intercept. Alright, on page 36, at the bottom of page 36, it talks about multiplicity. In that last example, we had 2 positive 1s that repeated. So that multiplicity means the number of times it's repeated. So in this one right here, if we go back to that example, the positive 1s, when we solved them, we had -1, +1, and -1. So your answer with a multiplicity in it would be -1 multiplicity of 2. It means there's 2 of them. You may also see multiplicity as a number of terms. So if you had an exponent of 5, your multiplicity would be 5 terms. Alright, on page 37. How do the following affect the graph of a polynomial function? So this page is kind of a summary. So the degree, that highest exponent, tells me the number of terms and my end behavior. Where's it going? That leading coefficient tells me how to start. If it's positive, it's going to start one way. If it's negative, it's going to flip and start the other way. Or you may see that as a reflection. The multiplicity of zeros is the number of terms. And repeating answers, repeating zeros. Or x-intercepts. So at the bottom of page 37, there's one to actually graph and identify all that stuff. So if I look at negative 2x to the 4th plus 4x squared minus 2, my highest degree is a 4. My leading coefficient, the number in front of that, is a negative 2. So that negative 2 means it's going to flip. So my degree is positive. No, my degree is even. Sorry. So that means they're all going in one direction. The negative 2 means that it's going to flip. So my end behavior is both of them going down. Alright, for my y-intercept, I'm plugging in 0 for all my x's. I'm going to go back to page 33 and make a note of that. So for x-intercept, we're going to factor and solve. For the y-intercept, we're going to plug 0 in for x, and that's for every single x in that problem. So if we go back to page 37, and I want to find my y-intercept, I'm going to plug 0 in for every x. So I'm going to have negative 2 times 0 to the 4th plus 4 times 0 squared minus 2. And you're going to figure out pretty soon that your y-intercept, when you go back and plug x in it, is just that constant. So my y-intercept is negative 2. The zeros are my x-intercepts, and I'm going to factor. So I'm going to take out, let's see, I've got a GCF. So I'm going to take out a negative 2. That leaves me with x to the 4th plus x squared minus 1. I'm going to x method that, and I get negative 2 x squared minus 1 and x squared. Oh, come on. No, I did make a mistake. That should be minus 2x. So I've still got a difference of squares. So I'm going to erase this so I can keep going. So if I break all that down, I've got x plus 1, x minus 1, x plus 1, and x minus 1. So a lot of factors. So I've got some multiplicity here. I can go ahead and see that because some stuff repeats. So I'm going to set each of those equal to 0. And I don't have to write the repeating numbers for the zeros because I'm only going to put a spot at one of them. So I've got a negative 1 and a positive 1 for my zeros. But my multiplicity, I've got, first of all, I've got 4 terms. And I've got negative 1, multiplicity of 2, means it repeats twice, and positive 1, with the multiplicity of 2. Now the 2 out here, the GCF, when I set each of those equal to 0, if I set my GCF equal to 0, that doesn't work, it's not true, so I just kind of ignore that number. Alright, so I found all my information, so now I'm going to put it on a graph. So I'm going to start with my intercepts. I've got a y-intercept at -2, and I've got zeros or x-intercepts at -1 and 1. And I've got 4 turns, and my end behavior start low and end low. So that's going to look start low, 1, 2, 3, 4. And that gets a little hairy when you're doing all the turns. All right, we've got one more example. If you want to pause it and try this last one, go ahead and pause. All right, so my degree, my highest exponent is 3. My leading coefficient is 1. My end behavior, because it's odd, means I'm going to have different directions. My leading coefficient is positive, so I'm going to start low and end high. My x-intercept, when I plug zeros in for all that stuff, I'm left with nothing. So my y-intercept is 0. My zeros are my x-intercepts. If I take out an x, factor that out, I get a 0 from this one, so that set equals a 0. Set this one equal to 0, and I get 2. That one equal to 0, and I get -1. In my multiplicity, nothing repeated, but I have 3 terms. So I'm going to put all that on my graph. So my zeros, I've got 0, 2, and -1. My y-intercept is also at 0, but I've already got a point there. And my end behavior is going to start low and end high, and